You're already very familiar with the idea of dividing numbers. If I divide the integer 23 by the integer 4, I get 5 and a remainder of 3. I could then rewrite this statement to say that 23 is equal to 5 times 4 plus 3. The three numbers on the right hand side of this equation now have different names. We have a remainder, we have a divisor, and we have a quotient. If we do a division of polynomials, the same ideas still exist. If we divide the polynomial p of x by a divisor d of x, we'll end up with a quotient q of x and possibly a remainder r of x. We could then rewrite this statement so that we have p of x is equal to q of x d of x plus r of x. So here we'll try to do a polynomial division. We'll divide x cubed plus 4x squared plus 3x minus 1 by x minus 2. I'll set it out as a long division in a manner in which you should be familiar with from your GCSE work. So I need to know what I need to multiply the x by to get an x cubed, and of course I need an x squared. I then multiply x squared by the x minus 2 to get x cubed minus 2x squared. I subtract these two terms to get 6x squared, and I drop the 3x down. I now ask the question, what do I need to multiply the x by to get the 6x squared? And of course I need a 6x. Multiplying the 6x by the x minus 2 gives me 6x squared minus 12x. Subtracting these two terms gives me 15x. And dropping the minus 1 down, I now need to multiply the x by 15 to get the 15x, and multiplying 15 by x minus 2 gives you 15x minus 30, and subtracting these two terms gives me a remainder of 29. There is an alternative method of doing this, which I call juggling the factors. I know that I have my polynomial, and it would be equal to my divisor times by the quotient plus possibly a remainder. So I look at the terms in my polynomial and the terms that are in my divisor to try and figure out the terms in my quotient. So I need to multiply this x by an x squared to get the x cubed. It also gives me a minus 2x squared, but I need 4x squared, and therefore I need to add another 6x, which will multiply together with this x to give me the 6x squared. It will also give me a minus 12x. I only want a 3x, and so I need to add another 15x. So if I add a 15, my 15x comes there, but it also gives me a minus 30. I only want a minus 1, and so I add 29. This is my divisor, this is my quotient, and here I have my remainder of 29. We'll do another example. I have to say at this point it's probably an idea if you pause the video and have a quick go at this yourself first. I'll do long division first, setting it out in the usual manner. I need to multiply the x by an x squared to get an x cubed. Multiplying the x squared by an x minus 1 gives me x cubed minus x squared. I'm subtracting these terms, I end up with a 5x squared. I drop the minus 4x down. Now I need to multiply the x by 5x to get 5x squared. Multiplying through again gives me 5x squared minus 5x, and subtracting these two terms gives me a single x, and drop the minus 1 down. I now need to multiply by 1, which again gives me the x minus 1, and so I end up with no remainder. An alternative method of doing this: start with a polynomial that I'm dividing. This is my divisor, so I need an x squared to make that x cubed. This would also give me a minus x squared, but I want a 4x squared, so I need another 5x. This would also give me a minus 5x, but I only want a minus 4x. So if I add 1 when I multiply it through, I get the extra x that I need. From the last two terms in each bracket, I get the minus 1. Okay, one more example. Again, you might want to try this yourself first. Setting it out as a long division. So first of all I need an x, multiplying through gives me the x cubed, and it also gives me a 3x. Subtracting these terms gives me a minus x, and I'll drop the minus 1. So now I have x cubed plus 2x minus 1 must equal x times by x squared plus 3. And I have a remainder which is minus x minus 1, but actually I'll write this as minus x plus 1.